Next, let's look at the example about the impedance conversion of the ideal transformer. This is a voltage source with very large resistance. That is to say, it is very likely a model of the current source. The load is 10 ohm resistance. Through the impedance conversion of the ideal transformer, the load can achieve the maximum power. It is very simple using the conclusion of the previous slides. Because seen from the source, the primary side of the transformer can be equivalent to an impedance of N squared RL. Then the whole circuit is a resistive circuit. The circuit will achieve the maximum power transfer when N squared RL equals Rs. Substituted all known values into it, we can easily find that N equals 10. According to the conclusion we discussed in the last slide, the ideal transformer itself doesn't store and dissipate energy, so all the active power is delivered to the load. So we realize the maximum power transfer by using the ideal transformer. Next, let's look at another example. We need to find the primary voltage U of the ideal transformer in this example. We can certainly list two port equations of the ideal transformer, listing a KVL equation at the primary side and a KVL equation at the secondary side. Coupled these four equations, we can find U. But here I would like to introduce you a more concise and intuitive solution method. We observed the equation of the ideal transformer, and we can find that if we assume that the voltage of side 1 is a variable U and the voltage of side N is a variable NU. Similarly, for the current equation, if we assume that a variable current flows into the dot of side N, then according to the conclusion of the minus 1 over N, we know that the current of side 1 flows out of the dot is Ni. After such an observation, two equations of the transformer can be integrated into the circuit, which sometimes can greatly facilitate our solution. Specific for the example, we are interested in the U of side 1, so it's convenient to write 10U at side 10. We can also assume that the current of side 10 flows into the dot is I. According to the discussion just now, the current of side 1 flowing out of the dot is 10I. We can write the algebraic equations about U and I by using KVL at the primary and the secondary side. At the secondary side, we have applying KVL at the primary side, we can know that coupled these two equations, it's easy to solve that. You can compare the method of writing four equations and the method integrating two equations into the circuit and writing two equations. Although their essence are the same, you will surely find out that the latter is much easier. Well, that's the end of this lecture.